Hey, Miss Wiggins, can we do physics? Physics, 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 physics.
I'm gonna study projectiles, independent, horizontal, vertical motion. Hot and calculating, looking for an answer. This is freaking awesome.
Now, maintain a constant horizontal velocity. This means zero acceleration. Holla! Constant vertical acceleration of g, or 10 meters per second square. That means vertical acceleration is in free fall.
In vertical velocity, use the following equation: v equals v naught plus at. That's not all, then there's other ones too. Use x equals x naught plus v naught plus 1/2 at squared to find the distance fallen by the shoe. Rid of the 1/2 at squared to find the range of that too. One last equation if you're trying to find t. V squared equals v naught squared plus 2a x minus x naught.
Hey, Miss Wiggins, can I borrow a calculator?
No.
Hey, can I have that microscope?
No.
Can I borrow a graduated cylinder?
Chad, go away.
Hey, Coach O'Breezy, can I borrow a pencil?
Sure.
Oh, sweet, thanks.
Horizontally angular, free fall in g equals 10 meters per second. On to the definitions, man. Time. The only thing that is the same for both variables. Range. How far something goes. Always determined by combination of time in the air and b horizontal. On time in the air, in HLPM depends only on the height. In ALPM depends on v vertical initial. In ALPM, min speed at the top and max speed at the bottom. In ALPM, same magnitude of velocity at ends, but up is positive and down is negative. A person standing on a bridge throws a stone with an initial velocity of 15 meters per second directed at 25 degrees from the horizontal and experiences no appreciable air resistance as it travels. Its range is 200 meters. How high is the bridge? Pause. Coming at you with a super easy problem. So the first thing we do is we know that our velocity is 15 meters per second. So we split that into its components, Vx and Vy. We know that y is sine since it is opposite over hypotenuse, and x is cosine since it's adjacent over hypotenuse. We then plug these values into our t-table. We also know that our range is 200 meters, so our x final in the x direction is 200, while we're solving for height, so our x initial in the y direction is where the question mark goes. Next thing we got to do is we have to solve for time. Since we have the most information about our x variables, that's what we'll use to solve for time using the following equation. I kept time in its numbers forms. I didn't actually solve out for it because we're not done yet. So we go over to our y variables. Since height is, after all, a y variable, it's our y initial. So we know our y final is going to be 0 since that's when the stone actually hits the ground. So we plug in 0 right here. Along with our other variables, we just plug and chug from our table to solve for y naught, and we end up with 990 meters for our height, or y naught.
Graphs: HLPM, y versus t, Vy versus t, ALPM, y versus t, Vx versus t, x versus t, Vy versus t. Hey, do you get it now?